So here is your third question of the exercise, which says prove that the following are irrational. Okay, so in the first one is prove that 1 upon root 2 is a irrational number. So we will be doing it similarly as we had done the previous one. Okay, so we will be considering this 1 upon root 2 as a rational number. So let 1 upon root 2 is rational number. Rational number. So if it is a rational number, then it will hold this property of rational number, that is p upon q, that is it can be expressed in the form of p upon q. Okay, so if 1 upon root 2 is p upon q, then root 2 will be what? It will be q upon p. Okay, so here we know that p upon q is a rational number. Okay, so q upon p will also be a rational number. Why? Because there is a property of reciprocal, okay, or existence of inverse, we can say, that we have studied in class 8. Okay, existence of inverse is there for the rational number. Okay, so that is why we can say if p upon q is a rational number, then q upon p will also be a rational number. So we can say now, since p upon q is a rational number, hence q upon p will also be a rational number. So q upon p is a rational number, but it is equals to a irrational number square root 2. So this can't be happen. Okay, why? Because one rational number cannot be equals to one irrational number. Okay, so this is a contradiction, and it arises due to our false assumption, and our assumption was 1 upon root 2 is a rational number. Okay, that was our assumption. So now it is wrong. That means it is what? 1 upon root 2 is what? A irrational number. So we'll write it also be a rational number, but it is equals to an irrational number root 2. This contradiction arises due to our false assumption hence 1 upon root 2 is irrational. Okay student, so the remaining two part of the third one question will be as same as we had done this one. So here they are. In the second part it says that you have to prove 7 root 5 is irrational. So for proving 7 root 5 a irrational number, we will be considering 7 root 5 as a rational number. So it will hold a property of rational number, that is it can be expressed in the form of p upon q. So again 7 is in the multiplication with root 5, so it will go on in division. So root 5 is equals to p upon 7q. Now again, since p upon q is a rational number, so p upon 7q will also be a rational number, but it is equals to a irrational number root 5. So this is a contradiction, because one rational number cannot be equals to a irrational number. So this contradiction arises due to our false assumption. Therefore 7 root 5 is an irrational number. Now here the third part of it, So in that we have to prove 6 plus root 2 is an irrational number. So for that we will be assuming that 6 plus root 2 is a rational number. So 6 plus root 2 we can express it as in the form of p upon q. Now this 6 is in the addition with the root 2, so it will go in the subtraction in the right hand side. So square root 2 is equals to p upon q minus 6. Hence again p upon q is a rational number, so p upon q minus 6 will also be a rational number. So if it is a rational number but it is equals to an irrational number square root 2, this cannot be happen. Okay, this is a contradiction. So this contradiction arises due to our false assumption. And what was our false assumption? It was that 6 plus root 2 is a rational number. So we can say that therefore 6 plus root 2 is an irrational number. So this is the end of this exercise. So stay tuned for more.